Hello guys, today we'll be talking about problem 4 from homework 4. So first things first, let's read the problem statement. It says equivalent force couple systems on a machine component. Machine component is subject to the forces shown, each of which is parallel to one of the coordinate axes. Identify the force couple at A which replaces these forces. So it's asking for the force couple at A, so we know we have to find R vector at A and vector at A. So in this case we have X, Y, and Z direction, so it's a three-dimensional problem. So first I will start with the x-axis, doing the sum of the force on the x-axis. This is the positive convention. This is positive for y, positive for z. So sum of force on the x direction is only this 300 newtons. So we have minus 300 newtons on the I hat direction. Now we go to the y direction, we have only this one. So we have minus 240 newtons on the j hat. On the z, we have these two, so they kind of react to each other. So 125 is going in the negative direction, 150 is going in the positive, so we get minus 125 plus 150, so we get 25 newtons on the k hat direction. Okay, that's for the forces. Now for the moments, the positive convention is put your thumb along the axis of interest, and then you curve your fingers around it. So this is positive for the x direction. So we gotta see which forces generate a moment in that direction or just on the negative direction as well. So the forces that do generate moment will be this one, 150. But remember, we have to do about point A. So let's say this is point A. So we'll generate a moment. So in this case, it will be the 120. So it's 1.120. So let's see. So it's this 125 generates 1, and then also the 150. So this 150. So the perpendicular distance, this is the distance. We can either do it by inspection or you can get the vector, so you know the formula M about A vector. You could just do vector cross F vector. So in this case, you could do it from this point to this point. You got the force, or so. But in this case, I would say it's easier just to do it by inspection. So just a thought. So we can just do, okay, now on the x-axis first. So let's say x-axis. So we get, so this one's going rotating this way. So this is going to be negative for the 125. Perpendicular distance is this. So 120 millimeters. So if we compare it to meters, it's 120.120 meters cross 125 newtons. We end up with minus 15 because it's going on the opposite direction of the positive. It's on the I hat. Then we have the 150, so that's this distance, 50 plus 30. This that's 150 newtons. So we'll get 12 newtons meters on the I hat. That's for the x-axis. Y-axis, we'll get a different color. So if we delete what generates a moment along the y-axis. So in this case, we have this 300 newtons, makes it rotate this way. And then we also have 150, this one, that makes it rotate this way. So say, see the distance as well, 60, so 300 as well. So we get, this is for the 300. We get 0.075 meters times 300 newtons. We end up with positive 22.5 meters. J hat, we get 0.06 meters across 150 newtons. That gives us a negative newtons meters j hat. If we do the c-axis, z-axis, there's only one that's causing the moment about the z-axis. In this case, is that this force. Rotate this way. So we get 0.03 meters. That's 300 newtons equals 9 meters on the K. Okay. So summing these up, summing these two and these, and this is by itself, we get the following. So if we add them up, we get -3 newtons meters on the I hat plus 13.5 newton meters on the j hat, and then plus 9 newton meters on the k hat. So this is our final answer. So thank you guys for watching. That's everything for this video.